Looking at this, we are going to continue with polynomials, and we are going to factor some more polynomials. So we have already done factoring throughout the year. So looking at this, we have done regular trinomials, and we did ones that looked like this. So we had 2a squared minus 3a minus 20. So in our class, we did the slide and divide method. So remember, you're going to slide your a over. So I'm looking for two things that multiply to give me a negative 40, and those same two numbers you're going to have to add to give me that middle term of negative 3. Once we found these two numbers, which would be negative 8 and 5, we're going to go ahead and write those in parentheses. And then that last step we always divided by a. So this would give me a minus 4. This one does not divide evenly, so I slide that to the front, so that gives me 2a plus 5. So this would be the factored form of that trinomial. So that's what we've done previously. We've also done a difference of squares. So remember, with this difference of squares, you can still do the slide and divide method. It still works. But the shortcut way for this one, we go ahead and write our parentheses. And remember, we would square root the first one. So that's going to give me a 3y. And then we square root the last number, so the square root of 16 would be a 4. So I would have a positive 4 and a negative 4, and that would be the factored form. Okay, so looking at this, this is what we have already done as far as factoring polynomials. So now we're going to look at some larger polynomials that have a different exponent other than a 2. All right, so the first one we're going to look at is we are going to look at a sum of cubes. Okay, so looking at a sum of cubes, this is what the example is going to look like. It's going to be 8m to the third plus 1. So first of all, sum means to add. Okay, and so looking at this, I only have two terms, but that degree is 3 because that's the largest exponent. So this would be an example of a sum of cubes. So there is a set rule for this. So the set rule for the sum of cubes, when I factor it out, I'm going to do a plus b in the first parentheses. And then in the second parentheses, I'm going to have a squared minus ab plus b squared. So this is a set formula for your sum of squares. So the only thing you have to figure out is what is your a and what is your b. So to figure your a and b out, you cube root each one of your terms. Okay, so because it's a cube right here, I'm going to cube root this. So if I take the cube root of 8, that gives me 2 right there. Okay, and then looking at that, the m cubed would be just 2m. So that is your a value. So if I cube root 1, my b value is going to be 1. So this is the first concept that you have to figure out, is what is your a value and what is your b value. And all you have to do is cube root each one of your terms, and that gives you your a and your b. So now, to write the factored form, I'm going to follow along with this. So my first parentheses is just going to be a plus b. So my a plus b is the 2m plus 1. Because my a is 2m, my b is 1. So I'm going to plug that in. And then here, for this part, I'm going to do a squared. So again, my a is 2m. So if I square that, I get 4m squared. And then I'm going to do minus a times b. So now I'm going to do a times b. So 2m times 1, I'm going to put a minus 2m. And then this last one, a b squared, I'm going to square my b value, which my b value was just 1. So that would be a positive 1. And this would be the factored form of that sum of cubes. Okay, so let's try another one. So looking at this, let's try if I have f to the third plus 125. So that's a sum of cubes. So I have to find my a and my b value first. So my a value, I'm going to cube root my first term. So the cube root of f to the third would just be f. Then I'm going to cube root the 125. So your b value is 5. So here's my a and here's my b. So now I'm just going to take those values and plug it into this set form. So my first parentheses is a plus b. So that would be f plus 5. And then my second parentheses, I'm going to do a squared. So that would be f squared minus a times b. So if I multiply these, I get 5f. And then plus the b squared. So 5 squared is 25. And that would be my factored form. Okay. So looking at this again, you have a set formula for the sum of squares. Now looking at this next one, we're going to do one more with this. So if I look at this one, 2w to the third plus 54. Okay, so remember, no matter what I'm factoring, I do always want to look for a greatest common factor first. So if I notice for this one, they are both divisible by 2. So I do want to take out that greatest common factor first. So this is going to leave me with w to the third plus 27. Okay, so now I have right here a sum of cubes. So looking at this, I am going to label my a value. So I'm not really worried about the 2 right now. So my a value is the cubed root of this one. So that's just going to be w. My b value is the cubed root of 27, which is 3. So these are my 2 numbers. So I am going to put the 2 in the front because that just carries over to my answer. Remember, the first parentheses is a plus b. So I'm going to do w plus 3. And then the second parentheses is a squared minus 2 times a, so I'm multiplying these, plus b squared. So that would be my factored form. So don't forget, you're always looking for a GCF. So no matter what type of factoring, you always want to look to see if there's something in common you can take out. And then once we took out that 2, we had that sum of cubes right here. So we're using that set formula again, a plus b in the first parentheses, and then a squared minus ab plus b squared. Okay. Now, so that was the sum of cubes. So now we're going to look at a difference of cubes. So this is going to be a difference of cubes. So really the only difference between this and the ones that we just did, instead of seeing an addition sign, you're going to see a subtraction sign, and that should be 3. Okay, so instead of that addition sign, you're going to see a subtraction sign. So again, we're going to have a set formula, and this time, instead of a plus b, we're going to do a minus b in the first parentheses. And then in the second parentheses, I have a squared plus ab plus b squared. So all of these in the second parentheses are addition signs, and that first one's going to be a subtraction sign. Okay, so looking at this, again, my a value, I'm going to cube root the first term. So the cube root of 64, g to the third, is going to be 4g. So that's my a value. My b value is the cube root of 1, which is just 1. Okay, so now looking at this, if I want to factor this, I'm setting this formula. So I'm doing a minus b, so 4g minus 1. And then I have a squared. So if I square this, 4 squared is 16. And then a times b, which is going to be 4g. And then b squared is 1. So that would be my factored form. So very similar to what we did. It's just a couple different signs. But you still have to identify your a and your b right there. Okay? So looking at this, couple things with this factoring with some of these, make sure you factor it out all the way. So this was the difference of cubes, and we can do another one. So let's say if I have 8a to the third minus 27. Okay, so let's go ahead and try this one. My a value, I'm going to cube root this, so that would be 2a. My b value, I'm going to cube root the 27, and that's going to give me 3. So now I have my a and b, so I'm going to plug it into this formula. So I'm going to do a minus b, so that would be 2a minus 3. And then a squared plus a times b. So if I multiply these two, I'm going to get 6a, and then plus b squared. So that would be the factored form. Okay, so again, very similar to the sum of cubes, the difference of cubes, you just have some different addition and subtraction signs in the different places. Okay, so like I said earlier, make sure we always factor out all the way. So looking at this example, and these are some just different examples before we do another one. So looking at this, if I have b to the fourth minus 36, so now this is a 4, okay, so it's not the difference of cubes, but here it's actually a difference of squares, and we talked about this on the first page, because if I look at this, these are perfect square roots. Okay, so if I look at this one and factor it out, the square root of b to the fourth is b squared. Square root of 36 is 6. So I'm going to have a plus 6 and minus 6. So what I mean by factoring it all the way out is just make sure you double check to make sure you can't factor it out further, which this one I cannot, so I'm good. But if I look at this one, if I do k to the 4th minus 81, okay, still a difference of squares. They're perfect square roots. So I'm just going to square root them. So the square root of k to the 4th is k squared. Square root of 81 is 9. So looking at this, notice I'm not done factoring. I can't do anything to this one, okay? That's a squared, so it's not a sum of cubes. This is a square, so I can't do anything to that one. So that one is going to be brought down. But if I look at this one, I can factor this one again because these are now both perfect square roots. So this is what I mean by factoring it all the way. So just make sure you always double check your answer. If you end up with another perfect square root, or even if it was a difference of cubes, make sure you factor it out again if you can. So this one actually has 3 factors. So that's what I mean by factoring it out all the way. All right, last type of factoring is we're going to do factoring by grouping. So this is the last type of factoring that we're going to talk about. And so looking at this, when we're talking about grouping, you are just going to group the first 2 terms and the last 2. So you're going to put parentheses around those first 2 terms and then around the last 2 terms. And then in those parentheses, you are looking for a GCF. Okay? So you have to take out the GCF of both of those parentheses. When you are done, whatever's in parentheses should be the same because that is going to be one of your factors. So whatever you have left in parentheses should be the same. Whatever is on the outside of the parentheses is your other factor. So again, this is going to make a little bit more sense once we do some examples. Okay, but we are going to group the first 2 terms and the last 2, and then we are going to look for a GCF to take out. Okay, so for example, if I have c to the 3rd plus 2c squared minus 4c minus 8. Okay, I can't do the slide and divide method because it's not a trinomial. This is not a sum or a difference of cubes. So looking at this one, it has 4 terms. So when it has 4 terms like this, we are going to group the first 2 and group the last 2. Make sure you realize that subtraction is attached to that 4. So that's why I put my parentheses here. So looking at just this first set of parentheses, you have to take out the greatest common factor. So if I look at that, they have a c squared in common. So I'm going to take out the c squared, and that leaves me with c plus 2. Okay, now I'm going to do the same thing for this parentheses. Now I'm looking at this parentheses and saying, okay, what do they have in common that I can take out? I will tell you a little hint. If that first number is a minus, a negative right there, you're going to take out a negative. Okay, so right here, they are both divisible by 4, and I'm going to take out a negative 4. When I take out that negative 4, when I divide negative 4 by negative 4, it gives me a positive 1c. And then negative 8 divided by negative 4 gives me a positive 2. So in this second parentheses, if that first number is a negative, that tells you you're going to take out a negative for your greatest common factor. Okay, so now looking at, this is what I said, your parentheses should be the same because that is one of my factors. So you're going to write this as one of your factors. The other factor is what you took out. So that would be the c squared minus 4. So one factor should be in parentheses. It should be the same, and you write that down once. That's one of your factors. The other factor is what you took out on the outside. Now, this is what we just talked about. Make sure I factor it out all the way. So I can't do anything else with this one. But here, I can factor that out more because this is a difference of squares. These are both perfect square roots. So this would be a c plus 2 and then a c minus 2. And that would be the complete factored form. Now notice you do have both of them, 2 of them that are the same. So if you want to write that one as a squared, you can. So because these 2 are the same, you can either leave it written like this or you can write it as a squared. It's the same concept. Okay, but for grouping, again, group the first 2, take out a greatest common factor, group the second 2, and take out a greatest common factor. Your parentheses should always be the same. All right, so let's try another one of those. So we're going to have 9z to the third plus 18z squared minus 4z minus 8. Okay, so looking at this, we're going to group the first two and then group the last two. All right, so looking at that first set of parentheses, they're both divisible by 9. And then the smallest exponent I'm taking out would be a z squared. So just from that first parentheses, the greatest common factor is 9z squared. So I am left with z plus 2. Okay, so now looking at this one, same concept, very similar to the one that we just did. This first number is a negative, so I am going to take out a negative 4. And that would leave me with a positive z plus 2. So right here, my parentheses are the same. That is one of my answers. And then what I took out would be the other factor in parentheses. So that would be the 9z squared minus 4. And again, this one, hopefully you notice, is a perfect difference of perfect squares. So the z plus 2 stays. And then this one, I need to break down and factor it again. So these are both perfect square roots. So right here, the square root of 9 is going to give me the 3, and the square root of 4 is 2. So I'm going to have 3z plus 2 and 3z minus 2. And that would be the complete factored form. All right, so looking at this, again, multiple ways to factor these polynomials. You just have to look at what you're given. So if you're given 4 terms, you need to do the grouping, and then you could also have that difference of cubes or the sum of cubes. Okay, so now realize what we've been doing with this factoring is we've been solving polynomials. So we're going to do a couple examples of solving those polynomials with this factoring. So it's going to tell you to solve or find the zeros. So remember, if I'm finding the zeros, it's the same concept as far as factoring that out and finding those x-intercepts. Okay, so let's look at the first one. If I give you, so some of them we have already done. So like if I give you this, 3d to the third plus 15d squared minus 18d equals 0. Okay, and I tell you to find the zeros, I'm asking you to solve it. Remember, I'm going to look for a greatest common factor. So they are all divisible by 3. And then they all have a variable. So remember, I take out the smallest one. So 3d would be the greatest common factor. So what I have left would be d squared plus 15d, oh, sorry, no, that would be 5, because I'm dividing, minus 6. Okay, so this is what I'm left with. So looking at this, this is a regular trinomial. So because this is a regular trinomial with the squared in the front, I'm going to do the slide and divide method. So I would be looking for two things that multiply to give me negative 6 and add to give me a positive 5. Okay, so looking at that, when I factor that out, this just drops down. So looking at this, your numbers would be a positive 6 and a negative 1. So those are the two numbers that work. So because it's a regular trinomial, we're doing the slide and divide method. Remember, I set each one of these equal to 0. So if I solve this set equal to 0, that gives me 0. This would give me negative 6, and that would give me a positive 1. So that's a little bit of a review of some regular factoring that we've done previously. Okay, so now looking at the next one, let's do one where it's kind of like the factoring that we just had. Okay, so let's do a grouping one. So if I give you this problem, so 6a to the third plus 30a squared equals 18a plus 90. Okay, so the first thing we're going to notice about this one, if I'm asking you to start to solve it, I don't have it set equal to 0. So I do want to move both of these to the other side. So that's going to give me 6a to the third plus 30a squared. Remember, when I move these over, they become the opposite. So that's going to become a minus 18a and a minus 90. All right, so now looking at this, first step, no matter what, we always look for a greatest common factor. So if I look at these numbers, they are pretty large. And looking at that, they are all divisible by 6. So I am going to take out that greatest common factor of 6, which leaves me with a to the third plus 5a squared minus 3a minus 15. Okay, so always take out that greatest common factor first. And now looking at it, if you notice right here, I can move that 6 over. I don't need to do anything with the 6. So this is what I'm factoring. So the 6 kind of just goes away. So now looking at this, it's a quartic. It has 4 terms. So looking at this, sorry, it's not a quartic. Looking at that, it's a cubic function, but it has 4 terms. So because it has 4 terms, I am going to do the grouping. That means I need to group the first 2 and take out a greatest common factor, and then I'm going to group the next one. So looking at the first one, they have a squared in common. So I can take out an a squared, and that leaves me with a plus 5. Looking here, they both are divisible by 3, and because this one is a negative, I'm going to take out a negative 3. And again, that leaves me with a plus 5. So now I've factored it out. Remember, one of my factors is what's in parentheses. So that's gone. And then the other factor is the a squared minus 3. So now looking at this, remember, I set each one equal to 0 and solve it. So this one's pretty easy. That one's going to give me a negative 5. But looking at this one, okay, so looking at this one, it's an a squared. I can't factor that anymore, so I do need to solve that. So here I can move the 3 over. And then this is where the square roots come into play. So remember, to get rid of a squared, I would square root both sides. So that would give me a positive negative square root of 3. So some of these answers, you can get square roots. We can even get imaginary numbers. So the next one we're going to do, we are going to get an imaginary number in our answer where we have to do that quadratic formula because it doesn't factor out. Okay? But looking at this, remember, anytime it asks you to solve or find the zeros of a function, you are just solving it by factoring or the quadratic formula here in a second, and then you are setting them equal to 0 to see what you get. Okay? So let's try another one. So let's try y to the third minus 512 equals 0. So notice it's a cubic. So I've got that cube right here. So this is a difference of cubes. So this is one where we have that set formula. Okay, so remember, for that set formula, I just got to find my a value and my b value. So looking at this, the cubed root of y to the third would be y. So that's my a. The cubed root of 512 is 8. Okay, so that's my a, that's my b. So set formula for the difference of cubes. I'm going to take a minus b. So that's my first parentheses. Second parentheses is a squared plus a times b plus b squared. Okay, so looking at that, that would be y minus 8 parentheses, the y squared plus 8y plus 64. Okay, so this is what I'm solving. So remember, the first thing we're going to do is we're going to factor it out. After we factor it out, we set each factor equal to 0 and solve it, but realizing I can't factor this one out anymore. So this one, I'm good. So I know one of my answers would be 8. So that one is good. Here, I can't factor this anymore. So looking at this, there's nothing that multiplies to give me 64 and adds to give me 8. So looking at this one, that means I'm going to solve this one by the quadratic formula. So remember, this is your a, your b, and your c in the quadratic formula. So the quadratic formula is the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So a little bit of a review from quadratic formula, because this one I cannot factor it out anymore to get it down to the y's. So looking at this, I have to solve this one by quadratic formula. Okay, so now looking at that for the quadratic formula, I'm going to keep simplifying this. So remember, we're always going to start with what's underneath that radical. So I'm going to simplify what's underneath that radical first. So I am just doing the 8 squared minus 4 times 1 times 64. And that gives me a negative 192. And then on the bottom, 2 times 1 is 2. So looking at this, the only thing I need to do now is I need to simplify this. Remember, we do that factor tree, and I am looking for factors of 192. So remember, I could go to y equals and type 192 divided by x. So looking at this, I want to start with positives. So again, you can start with any of these numbers. I'm going to start with 3 and 64. So 3 is prime. I'm going to break down 64 into 8 and 8. Neither one of those are prime. So I'm just going to keep breaking these down. So remember, with that factor tree, you want to break it down to nothing but primes. Okay? So looking at this, I have a pair of 2's, so I take that one out. I have another pair of 2's, so I take that one out, and then I have a third pair of 2's. So remember, everything with the factor tree is multiplication. So I have 3 pairs, so that's 2 times 2 times 2, which is 8. Now, also don't forget, that negative under that square root, that's that imaginary number. That negative pulls out as an I. And then that 3 was left over. That 3 didn't have a partner. That 3 has to go back under that radical. So this is a lot of review from some previous units. So looking at this quadratic formula, simplify what's under that radical, and then to simplify that number, we have to do the factor tree. Now also realize I can simplify these because these are all divisible by 2, so I can divide all those by 2. So this becomes a -4, that becomes a +4, and then on the bottom you would just have 1. So this is how I would leave my answer. So realize I have technically 3 answers because remember that plus and minus. So sometimes if it doesn't factor out to nothing but like the y, and you have a y squared left, you may have to use that quadratic formula. All right, so let's try one more of these before we look at a last little bit of a problem. So let's try one more. So let's try this one. So we're gonna say, I don't use that one. So we're gonna do x to the 5th minus 4x to the 3rd plus x squared minus 4 equals 0. So I'm asking you to find the zeros. I'm asking you to find those x-intercepts. So I have to factor this out. So looking at this, I've got 4 terms. So I'm going to go ahead and group the first 2 and then group the last 2 because there is no greatest common factor to take out. So if I look at my first set of parentheses, I can take out an x to the 3rd, and that leaves me with x squared minus 4. Oops, and then over here, I didn't mean to put that parentheses. So over here at this one, now realize when I'm looking at factoring by grouping, I have to take something out. So if I look at this parentheses, technically they don't really have anything in common other than 1. So right here, because they don't have anything else in common, I have to take out a 1. And because this first sign for that parentheses is a positive, I'm going to have a positive 1. And that leaves me with the x squared minus 4. Okay, so looking at this, my parentheses are the same. So that's x squared minus 4. Outside of my parentheses is the x to the 3rd plus 1. Now, it looks like these are my only 2 factors, but remember, I have to continue to factor. So if I look at this one, this is a difference of squares. So that becomes x plus 2, x minus 2. This one is a sum of cubes. So that's what we just did earlier in the lesson. So right here, I'm going to have to factor this one out. So you might want to write this over to the side. My a value, remember if I cube root this, so my a value is just a 1x. My b value is 1. So if I cube root 1, I get 1. So the sum of this cubes, I'm going to do I'm doing a plus b, so that's x plus 1. And then I got a squared minus a times b. And then right here, it's going to be plus b squared. So that was a lot of factoring. So even though I did grouping to start with, here, this was a difference of squares. Here, this was a sum of cubes. So I had to continue to factor that out. So looking at these, to solve this, I have to set each one of these equal to 0. So right here, these are pretty easy. This would give me a -2. That would give me a +2. That would give me a -1. So those 3, when I set them equal to 0 and solve, are very simple. If I set this one equal to 0, I have to do that quadratic formula. Okay, so I've got 3 of my answers so far. I got to find that 4th and 5th one. So looking at this, I'm going to do quadratic formula. So the opposite of b, which is going to be a +1, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And so realize it's pretty simple because a lot of them are ones, so that's really easy to work with. So right here, we're going to do the inside part first. So I'm doing negative 1 squared minus 4 times 1 times 1. So that gives me a negative 3. And then on the bottom, you just have 2. So now looking at this one, not really a lot to simplify because I can't break down 3, but also realize that is a negative. So when I write this one, I have to take out that I. So this would be my other answers. Okay, so again, if you factor everything out, these are pretty simple. You just set them equal to 0 and solve like a regular equation. If you are left with a squared, you're going to break that down using the quadratic formula. All right, so I know it's been a lot with factoring. Last concept for this is you have sometimes additional roots. So kind of like what we just did with that quadratic formula. Remember, when you have a square root, you always get a plus and a minus answer. So if I only give you one answer, you should be able to find the other answer and then write the equation of it. Okay, so remember, first of all, roots, it's the same thing as zeros, same thing as solutions, x-intercepts, they're all the same. So if I'm asking you for additional roots, so like say I say one equation has an answer or a 0 at 2i, what is the other root? It would just be a negative 2i. They're just opposites. So if I say one has a 0 at 14 minus the square root of 2, you're going to tell me the additional root would be at 14 plus the square root of 2. And that's that whole plus minus when you take a square root. Okay, you know you're going to have one positive and one negative. So if I only give you one of them, you can tell me what the other one is because you just take the opposite of it. Okay, one thing we're going to have to remember with this is that when we get those i's, those negatives, when we have an I squared, don't forget to simplify that to a negative 1. So we're going to see that here in a second. If I have an I squared when I'm simplifying, make sure you simplify it down to a negative 1. So for example, if I say write a function that has these zeros. So if I say the function has a 0 at negative 10i, I want you to write the function of it. Okay, so if I'm asking you to write the function of that one that has a root at negative 10i, what I didn't tell you and what you should know, the other root would be at a positive 10i. Okay, so I'm going to start writing my equation. And remember, I know if these are my zeros, I can write them in factored form first. So we can always write our zeros in factored form first. Remember, if this is a negative, when I write it in factored form, that would be the positive. If that one's a positive, that would be the negative. So you write them as the opposite. And then here, if I'm asking you to simplify it now, I'm just going to do that FOIL or that box method. So I'm going to get x squared plus 10i minus 10i minus 100i squared. Okay, so all I did was the FOIL method. And again, if I give you one of the solutions, you should be able to tell me the other solution because they're just opposites. And we've done this previously. If I give you a 0, I can write it in factored form, and then I can simplify that for my equation. Now, make sure we continue to simplify this. Those are going to cancel out. This is where I talked about if I have I squared, that's a negative 1. So when I simplify this, negative 100 times a negative 1, my equation would be x squared plus 100. So that is the equation that would have those solutions. Okay, so again, if I give you one root, you can find the other one, and then you can use it to write your equation. So let's try one more. So last problem, if I tell you that it has zeros at 3i and at 9. So I know already I can start to write my equation. So I would write the opposite of that. So that would be a minus 3i. I would write the opposite of that. Okay, but looking at this, if that one is a 3i, I know I have another answer that is a negative 3i. So that means I would have an x plus 3i as well as a factor. So if I give you these two, anytime you have an I or a square root, I know I should have an opposite one as well. Okay, so make sure I can write that in factored form, and then I would simplify it. So I'm actually going to go ahead and multiply these two first. So I'm going to do that off to the side. Let's do the box method as a review for the box method. So I'm going to multiply these two, so x minus 3i and then x plus 3i. So I'm multiplying these two first. So this gives me x squared negative 3ix, sorry. Then this would give me a positive. And then here, be careful, that's a negative 9i squared. Don't forget to add your exponents. So when you're multiplying, don't forget to add those exponents. And then right here, notice, those in the middle are going to cancel out. So when I multiply these two, I am left with x squared minus 9i squared. Now, looking at this, remember, I can simplify this. So if this is I squared, this is really a negative 9 times negative 1. So what's negative 9 times negative 1? So that would be a plus 9. So make sure we simplify this one all the way down. So the I squared turns into a negative 1. So this is really x squared plus 9. So now I can multiply it by that last one. Again, we can draw another box. So that's x squared plus 9 and x minus 9. So looking at this, that's going to give me x to the third, 9x, negative 9x squared, and a negative 81. So just be careful with this box because you're multiplying an x squared and an x. When I write my answer, I have an x to the third. These are not like terms because of the difference of the exponents. So just make sure I'm writing it in standard form. And then that minus 81. So that would be the equation that has those solutions. So we have previously talked about if I give you solutions, you should be able to write the equation. Okay, the only thing you have to be careful about, anytime one of your solutions is either an imaginary or a square root, you have to make sure you have the other answer as part of your problem. Okay, so if I give you a negative 10i for a solution, you automatically should know that the other answer is a positive 10i. So a lot of factoring today. So some of the new factoring, make sure we understand the sum of cubes and those difference of cubes and the grouping method.